This conference will now be recorded.
Great. Just to reiterate for the people who are going to be watching the recording, we're going to miss the next 2 weeks because school closures. We'll be back on September. Somebody give me the right date. 26th, is it? Tuesday the 26th. Am I right about that? 26th, right? 25th. Okay, we'll be back on Tuesday the 25th. In the meantime, I'll be posting assignment 1 in 3 parts, part A, part B, part C, and they'll be covering different things. Like we're going to talk about age adjustment. We're going to talk about different data types. We're going to be talking, and we're going to spend a lot of time introducing Excel and SPSS. So it becomes a useful tool for you as the semester goes on, and especially as you go into other courses as well. So keep an eye open for that. As I started to say, I do an online help review session for a strictly online biostatistics course. I do it on Thursdays from 4:30 to 5:30. I'll give you links to that each Thursday. You can tune in online, and you can, into the chat box, you can type questions, you can ask me to review material. A lot of materials kind of paralleling what you're doing here anyway. So you're invited to join that. Okay, so if you have any questions, any problems or stuff like that, bring them up. And also, one of the parts of assignment A that I'm going to be adding is a request that you post something. Probably I'm going to ask you to post something like, what's your name? Why are you taking this course? Or why, or what are your objectives or something like that. It's not intended to get personal information about you. You can write anything you want. You can make it up. I don't care. You can post a picture. You can post a picture of a pet. I don't care what you post, as long as it's reasonable. I just want you guys to get comfortable with using the discussions forum on Blackboard, because as you can imagine, a lot of people email me questions, right? And then because a lot of people have the same problems, I get the same question about 9 times. So it's much more efficient to use the discussions board to post those questions, and then I can answer them, or other students can volunteer answers for them. You can collaborate on the discussions forum as well. So I'm going to ask you to do a simple post so that I know that you know where it is and you know how to operate it. And part of your participation grade might be, remember there's some people here that don't have to show up at all, the other non-nutrition students don't have to show up, so a bigger part for them is going to be their participation in the discussions forums. Okay, and I'm not bending arms or anything like that, but just so you use it as you learn how to use it as a useful tool. So we're going to work on some of that. We're going to work on this today, some more stuff on Excel, SPSS. We're going to work on some other functions and stuff like that today. We're going to have that big gap. So I'm hoping that maybe you'll tune in on maybe I'll even do 1 or 2. Maybe I'll do a session just for us or something like that, so we can keep up. So you don't forget you're supposed to be here on Tuesday, right? I mean, 3 weeks is a long time. Yeah. So maybe I'll do something where you can participate online or something like that, and I can answer some questions. Okay. So before I get started on anything else, any questions, problems, issues, airing of grievances, anything like that going on? Not yet, not yet. Okay. All right, good. Not yet. All right, so good. Okay, so I'm going to do something a little unusual right now. Last week, I did kind of a PowerPoint on data types, introducing like histograms, bar charts, and stuff like that as part of the lab. I'm going to actually play a presentation, the version that you have on here. But the person that's talking is going to be another professor that I teach this course with at School of Public Health. So you get another view of it. Okay, so I'm gonna cue that up. And for you guys, I made it available on Blackboard just now. So if you guys that are online, rather than watching it through this, which might be a little choppy or something like that, you can just play it on your own computers. Okay, good. What's that? We're gonna open heights. Heights.xls, Excel file. Okay, we're going to open it in Excel. And as I said, if you're having an issue with downloading it, probably the best bet on these machines here is to right-click on the file. Right, on the Mac, it's Control-click. Right-click, say Save Link As, and navigate to the desktop, store it on the desktop so you can get to it. Okay, just so you know, anything you put on the desktops on any of these machines at midnight, they turn into pumpkins and everything gets erased. So the next day it's a clean machine. So if you're ever working with a file, you save it, you want to keep it with you, make sure you email it to yourself or copy it off to a memory stick or something like that. Okay, so right click, save as, and drop it on the desktop so you can work with it. The other reason why you don't want to click on it is because depending on what browser you're using, some browsers have the capability of opening an Excel file or another spreadsheet file in the window of the browser, but you can't. It's not really the program, so you can't actually work on it. So if you have that experience that, gee, I can't, I got this, I can click into the boxes, but it doesn't work, right? That's because you have it open in the browser rather than in the program. So make sure you open it in the program, download it, and then double click and open it in the program. So I'm going to open up my version, which is here. And I'm going to get rid of this stuff in the background. We don't need that. Good. Okay. So what do we have here? We have two variables. Notice the variables are listed in the columns. One variable is height, right? That's a numerical variable. It's inches in height. The other variable is gender, and it's labeled. It's coded as zeros and ones. Obviously, one of those is going to represent male. The other is going to represent female. I don't know which one it is. Okay, so if we want to find the middle values for height, now notice this I think is one of the ones that you were working with before this. Notice that there are some missing values in here, right? Notice that there's a missing value there. Excel will ignore empty cells when you do calculations like average, standard deviation, things like that. What it won't ignore is if there's something in there like text, like I'll go in here and I'll write something like missing or something like that, right? If I try and calculate the average on that, it'll come back with pound name or null or something like that, some sort of error, right? So we want to make sure that we don't have any mixed variable, any mixed data types in there for Excel to work with it. Okay, and so for right now, I'm not concerned too much about which one is males and which one is females. Let's say that I'm interested in finding the average weight for the sample that this sample, which was drawn from a population. Okay, and there are 182. We worked with this, I think, last week as well. Let's say we want to find the average height for this population, for this sample. So we're going to type in average. Okay, you guys can do it also. Parentheses. And then you're going to describe to it that range, A2 through A382. You can either type that in, A2, colon, A382, close parentheses, and hit enter, and it'll calculate the average for you. Notice that there's a lot of decimal places behind that by default. I can, if I want to, I can tell Excel to format that so that it rounds the number for me. I'm going to click on control, and I'm going to control click, right click, or control click on the Mac, and click on that cell and go down here to format cells. I'll click on format cells, and it's going to bring up a window where I can tell it that I want this number to be described as one decimal place, let's say. And how many decimal places? I'm going to click on OK, and it's 67.1. Okay, so it rounded it for me. Okay, however, the nice thing about Excel is even though it displays it a single decimal place, it actually remembers that number. So if I go over here and I say 2 times this number, this times 2, and hit enter, there's all my decimal places back again, right? So you don't lose that extra data. You're not really rounding it, which is great because in statistics, from now on, we're not even going to consider rounding anything until the very last step. And why is that? Well, that's because we very often will take data like we did before and we'll square it and we'll add it up and we'll find the square root of it and we'll do other operations. We'll add things to it, multiply things. What's going to happen is that each step, if you round in the beginning, you're going to multiply your error as you go through each step. So you don't want to round until the very last step, until you get to your answer, right? So, but Excel kind of helps us out on that. So one measure of the middle of this is the mean. What's another measure of the middle? Mode. Okay, we're talking about mode. Of course, we were saying that we don't like the mode, but that's a whole other issue, right? So let's figure out what the mode is. Mode, parentheses. Oops, I left out the equal sign. Okay, and it wants to know the range of numbers. A2, colon, A382. Enter. And the mode is 64. I'm going to put that in there. Is 64 mode. Okay, so mode is 64. That's the most frequently occurring value. How can I physically, if I wanted to see that, what's the best way for me to see that? You know, I could actually take all of these values. I can highlight them all. And I can tell Excel to sort the values for me. I'm going to highlight them. I'm going to go up to data. There's a couple of ways you can do this. One way is to go up to the menus at the top if they have them on your version, up to data and sort. And the other way is that there is typically a little sort symbol on the ribbon for the home tab in Excel. On the PCs, it'll be in a slightly different place. I can click on that, the little down arrow, and I can say ascending or descending. Okay, so ascending means the numbers go up, descending means the numbers go down. Okay, and it sorted them according to the value of the first column that we were working with. Oh no, actually it did something even nastier. No, it did the right thing, I think. I believe it did the right thing. Yes, it did do the right thing. Okay, so for what's that? Oh, you don't want to just hit sort. You want to click the little arrow down next to it so it gives you some choices. Does that help?
No, I have data sort.
You don't get this little drop menu that I'm getting?
I get a drop menu
Or-
for sort. Doesn't have a drop menu.
How about if you do it from the menu, data?
Yeah, that's
Sort.
what I'm doing. Yeah.
Okay, I'm going to go to data and then I'm going to say sort. Okay, did it come up like this? Kind of something like that?
Yeah.
Okay. Okay, good. So I'll show you how we use this version of it. Okay, now in this version, actually we can do a custom sort. One of the things that I didn't show you here is that if you go over here to this little sort button and click on the right side of it, whoops, I was in the wrong one, sort, click on the right, one of them is custom sort. And it brings up that same window. Okay, and when you do a custom sort, you can tell SPSS to sort by, and then you can actually choose which column, height or gender, right? So I could choose height or gender. I'm going to choose height and say okay. And it sorts it according to the left values. So I highlighted both columns because I don't want it to separate out. I don't want it to just sort that left column, the heights, and break each one of those values away from its gender that's associated with. So I highlighted both of them. So it'll actually sort both of them. Okay, so if you want, you could even go in here and say data sort, and you can say highlight sort by height, and then also after that, sort by gender. Okay, and it's going to take each height, group it, and then sort by sort into the groups gender and 0 and 1. Okay, and that's not going to be particularly useful, but here, for instance, if I get down here, you'll see that 66.5 is sorted so that 0's on top and 1's on the bottom in that group. So now we literally could, what did we say that the mode was? The mode was 64? Well, you actually can go over here and you can actually count out and see that that is the most frequent value that occurs in this sample that we have here. So that's just of some interest. We can actually sort this so we can see it a little bit better in Excel. So the sort is kind of our friend here. So what's the other value that we can use for the middle? The median, right? The middle value. Okay, so middle value equals middle value, median, and I'm gonna, again, A2 to A382. And that turns out to be 67. Okay, median. Okay, so what does that tell you about this distribution? What do you notice about the mean and the median? They're very similar, aren't they? Right? So that suggests that this distribution is relatively normal, right? That they're not, it's not as if the median is much different than the mean is. If the mean is much different than the median is. If the mean was much different than the median, what would we call that kind of distribution? Skewed, exactly, right. So if the median is much bigger than if the mean is much bigger than the median, what kind of skew is that? That's right skewed or positively skewed. It's pulled higher, right? Positively or to the right. Well, what about if the mean is much smaller than the median? That's negatively skewed or left skewed, right? Because it's pulling the mean down. It means that you have low values, extreme low values, and it's pulling the mean away from the median. Okay, so without actually drawing it, we can get an idea of what this kind of looks like. Okay, so now, how about measures of distribution? What kind of measures of distribution do we have? Let's start with the simplest one. What do you think? Range, right? Yeah,
I have a question about this one.
sure.
When we are citing the variable, how do we know that it's going to correspond with the variable's origin?
You could go back and check, right? Like in other words, here, watch what happens when I try and sort this, right? I'm gonna highlight this column. Okay, and let's say that I'm gonna go ahead and sort this. Whoops, I had clicked away. Crap. Can we do that again? Okay, I'm gonna highlight these numbers. Whoops. What's that? Yes, you can. Yeah, I was thinking it would be better anyway, right? Okay, so notice I only highlighted one column. So if I go up here and say sort, right? The problem now is if I just sort that column on the left, then I'm disconnecting the genders with the people whose heights are represented there, right? That's no good. SPSS actually warns me. You have selected only some of the available data. Only selected data will be sorted. What do you want to do? Expand the selection or continue with the current selection? So I want to expand the selection before I sort it, right? So I can go ahead and click sort, and it'll do this. It'll bring this up and allow me to customize the sort if I want to. Okay, so now I don't really care about this. I'm gonna gender. I'm just gonna get rid of it, leave it, and it's okay. It's already, this is already sorted. So it went ahead and sorted without messing up the corresponding values. Each one of these is still correct. Okay, so how about measuring the variability here? What statistics can we use to measure the variability? How about range? Right? How do we calculate the range? We find the minimum and the maximum, right? So that seems pretty simple. So what's the minimum? Well, you already know the minimum, don't you? We sorted it, right? So it's going to be 56. Well, let's go ahead and do it anyway. Okay, and what's the maximum? Max, parentheses, A2 through A382. And that's 91. If you scroll down, you'll see that it is 91. Notice it ignored the missing values. Didn't put in 0. But if you scroll down to the bottom here, because of the way we sorted it, there are blanks there, right? For those values, right? It ignores them, right? Doesn't actually use them in the calculations at all. Doesn't substitute 0. What's that? I'm sorry, I missed that. I just typed range. I didn't put anything in there. I just asked it for the minimum and the maximum. And the range, you can actually just calculate the range from the maximum minus the minimum. Okay, so the range is 35. The difference between the lowest height and the tallest height is 35 inches. So that's the range. We get an idea that, oh, but the spread is 35 inches. Is how wide these are. Minimum is 56 inches, right? The tallest person is 91 inches. How tall is 191? 91 inches sounds kind of hot, tall, right? What is that? So let's see. 6 is 6 is 72, 84 is 7. No, so yeah, 91 is ridiculous. That's an outlier, I would think, right? 91 is too tall to be normal. Okay, so what other measures of the range? Measures that are more appropriate for the kind of calculations we might be doing in the future, like for instance, the variance and the standard deviation. Okay, so what are those values? Equals VAR, parentheses, A2, colon, A382. And the variance is 16, and the standard deviation, there's two ways for us to calculate this. One is to just put in STDEV, parentheses, and A2. Sure. Okay. Yeah, you could open, you probably, if you wanted to, in the other computer or on your computer, you could open another window where you can watch. Okay. So standard deviation, we can do that two ways. One way is saying equals STDEV, parentheses, standard deviation, and then tell it the range of numbers. A2, colon, A382, and hit enter. Okay, so standard deviation is 4. That gives us a measure of how spread out the distribution is. Just as kind of like a preview of how we're going to use standard deviation in the future. If this sample was a random sample from a population, because the standard deviation is 4, we would say to ourselves, based on that, we can predict with some level of certainty, not 100%, we can predict with some level of certainty that the range of weights in that heights in that population is between 8 below the mean and 8 above the mean. And then the other 5% of the population are outside of that range if it's a normal distribution. In other words, we know it helps us understand the distribution even more than just looking at the range and so on and so forth. We don't need to know that right now, but just to point out that this is an important value to us going forward. What other way do I have that I can calculate the standard deviation? What is that? When we calculated the standard deviation by hand, how did we get it? We took the square root, SQRT, parentheses, of the variance, that's 16. Okay, yeah, let me finish up. Okay, okay, I'll do that first. So, yeah, I'll do it again. VAR, parentheses, and then the range of numbers, A2, colon, A382. And one of the things you can use to kind of like help yourself out is as you say to yourself, I want to calculate variance, I'm not sure that statistic exists in Excel. You could go up to this little function key and search for it, or you can start typing V, and you can see a bunch of the values below that. And sure enough, there is a function called variance. And I can click in instead of that, and then type in A2, colon, A382. So there's also kind of little crutches in Excel to help you with this stuff. Make sure you get the statistic right and you get the range right. You hit enter and it comes out to 16. Now, you'll notice standard deviation, I use the function STDEV, right? But we know that the standard deviation is the square root of the variance. So I could just use the function square root. As it happens, it's kind of a funny function in Excel. Equals, I'll start typing in square root SQ, and sure enough, there is a function called SQRT, which is square root. And then fill in A2. Yeah, actually, I'm not even going to do that. I don't want the square root of that whole range. I just want the square root of this value, which is the variance. I'm going to click into that cell to let it know that cell is at, find the square root of the value that's in F13 and hit enter. And sure enough, you get exactly the same value as you did when you used the standard deviation function. Okay, so this is really nice. We found out that this population has a mean of 67 inches in height. It has a median of, I'm skipping mode, has a median of 67. Sounds pretty normal. Okay, it's got a range of 35 inches from the shortest person to the tallest person. It's got a standard deviation of 4. So it's interesting. We're starting to get a handle on this. But there's two groups in this population. There's males and females, right? What if I want to compare the males and the females, right, in terms of height? Okay. Well, heights, we're going to figure that the females probably are taller than the male. The males are probably taller than the females. But let's actually test that theory. Okay. And one of the ways we can test that theory is to sort the data in Excel. Except this time, I'm not going to sort it by the height. I'm going to sort it by the gender. Sort. Bring up that custom sort box. I'm going to get rid of height. I'm going to add in a new sort and tell it I want to sort. Click into the columns box. Tell it I want to sort by gender. And I'm going to click OK. By the way, while I'm here, you notice that there's a little blue check mark in the top right hand corner. That's there because it's asking me is that it's a notice that there's text in the top row, and it's asking me, is that a header, that text, or should I include it in the sort? Right? Well, that's just a header. I want that height and gender to stay at the top. I don't want it included in the sort. So I'm checking off that is a header. Don't include it in the sort. I'm going to click OK, and now you can see that they're separated into males, whatever this is, females and males. Okay, so now let's compare them in terms of their middle value and their spread. And I'm just going to ask you for now to do just mean and standard deviation for these two groups. Okay, so this is the group 0, and over here is the group 1. Okay, that's kind of sloppy. It hangs over to the right. I'm going to highlight these two boxes. I'm going to right click on them or control click. Go down to format. Now again, that's the way I did it. I right clicked or control click on the Mac, and it gave me that drop menu. I went down to format cells. You could also go up to edit and format. You can also go through the menus, or you can go through the ribbon on Excel. Okay, there's a lot of ways to get to the same point. So I'm going to say format cells, and this time I'm just going to go into alignment, and I'm going to tell it that I want these centered horizontally. And I'm going to go into font, and I'm going to tell it that I want it to be bold. Let's see, bold. There we go. And I'll click OK. So there's our 0 and 1 now are bold, and they're in the center of the columns. So now I am going to calculate. I'm going to calculate the mean and the standard deviation for these two groups separately. So I'm going to do it first for 0, whatever that happens to be. So it's equal to, okay, the mean is the average, parentheses, and I'm going to click in here, click down, hold it down. It's starting at B2, and I'm going to pull down until I get all the zeros in here. Whoops. So it's B2 through B120. I'm going to hit enter, and it turns out that oh my goodness. Let me try this again. Equals, you guys know what I did there, right? Average, parentheses. I got to highlight the actual values, not the zeros, right? I'm going to click down A2 through A120, I guess it's going to be. Let's see if I'm right here. Is it A120? Yeah, it's A120. Right? Yeah, A120. I'm going to hit enter. And the average height for 0, whatever gender 0 is 70 inches. What about the standard deviation? The average standard deviation for that same sample is going to be equal to STDEV, parentheses, and it's A2 colon A120. I know what it is already, so I'm not going to bother to carry it all down. And the standard deviation is about 2.86. I'm going to do the same thing for the value 1 equals average, parentheses, and now I'm going to go down here and see where the ones start, and they start at 121, so I'm going to click on that first value, 56 inches for 121, and I'm going to scroll all the way down to the end. A121 to A382, not surprising there. And the average height is 63 inches. What happened to standard deviation? It's equal to STDEV parentheses A121, right, to A382. And I'm going to get the average height for all of those that are gender 1. Okay, so what do we wind up with? We wind up with 0 has an average height of 70 inches, and group 1 has gender 1 has an average height of 65 inches. So which ones are the males? Probably 0, right? Probably if I had this, normally we'd have a code book, which tells you, hey, this is how this data was coded, so you don't have to guess at it. But since we don't have that, we know now that this is the males and this is the females. Okay, which one has more variability in the height? Where is the variability greater, among males or females? Females, more variable, right? The standard deviation is more variable than it is for males. Not sure why, but why it came up that way this time around, but that's the way it looks. So it's pretty interesting stuff, right? We can do these various statistics. Okay, so now I'm going to look at, instead of doing it this way, let's get SPSS to help us out with this. Okay, so I'm going to close this file, but I'm not going to save it. You can save it as a new name if you want. Say click, or actually you can go into file and say save as, right? And save it as a new name, but I'm just going to close it. I'm going to reopen it. I'm not going to reopen it. I don't want to save these changes. The reason why I don't want to save these changes is because I want a clean file. I want a file that only has my 2 columns with my data that I want to work with in Excel. Then I'm going to go into and open SPSS. How many of you guys have gotten SPSS working on your machines so far? You guys are still struggling with that? That seems like a lot of people, not a lot of hands are going up. Okay, hopefully we'll really get that out of the way in this, while we're off this during this period, because you're going to want it to do that first assignment. Yeah, that's a problem. How about the other ones? Everybody else okay? Anybody else have a license expired on the PC? You want to try another machine? Oh, do you have it on your Mac? No, not yet? Okay. Why don't you try another machine? Or you can just watch me and give it a try when you get a chance. Okay, so what I'm going to do now, again, it opens up in this window. I don't need this particular window. I'm going to tell SPSS opens up with a blank window. I could, if I wanted to, start adding data here, right? Like I could just click into this and say, oh, this person's weight is 123 pounds. This person, and it's a male, so it's 0. This person's weight is 234 pounds, and that's a male, 0. This person's weight is 135 pounds. That's a female. I'll put a 1 in there. You could actually just start typing in data here if you wanted to. That's kind of tedious. We already have the data existing in Excel. Okay, so what I'm going to do instead is I'm going to say File, Open Data, open a data file. I'm going to navigate to the desktop, and I'm going to open that file in SPSS. I'm going to import it into SPSS. Now, I don't see it on the desktop because SPSS is now showing me only files of type SAV, its own data files. If I change this to Excel, I'll see only the Excel files. Here, I have a bunch of them on here as it happens, so you'll see a bunch of Excel files. Okay, if I want to see all the files, I could just go down here to say all files, and it shows me everything that's on my desktop. So since I'm looking for an Excel file, I'm just going to tell it, just look for Excel files. Okay, and sure enough, if I go over here, here's my heights file. I'm going to click on that and say open. Now, SPSS is going to examine that file before it imports it. And it's going to report to me that it sees data on sheet 1 of the worksheet. Remember, in Excel, you can have different tabs or worksheets, right? So sheet 1, that happens, there only one sheet anyway. Sheet 1 of the worksheet sees data between A1 and A382. That's right, because we know that we've just been working with it. We know that's where the data is. It also has a check mark there. Read variable names from the first row of data. That's checked. That's true for this data file because the first row has what in it? Not numbers, but height and gender, right? So we want SPSS to use that first row to name the data as a data file, as a variable name, not as part of the data. So I'm going to leave that checked. I'm going to say okay. Okay, and it will open. You get the output window will open up first. Went by real quick. And the output window gives us a summary of what we just did. We just went up to file, get data. We navigated to what file to get, and so on and so forth. If there's any special considerations, like the first line is variable name, it includes that. So this is literally, if we were to type this in as a program in SPSS or syntax, this is what it would look like. Okay, it just happens to do that in the output files. It's handy. Maybe every once in a while take a look at that because as we get towards the end of the semester, maybe we'll talk about that a little bit. Okay, so now it's imported this file into SPSS, and you can see it moved the height and the gender up here to show me that it's a that those are the variable names. So this is my data set. You can see all of these various values are in here, including the missing ones probably at the bottom there somewhere. 381, they're in here somewhere. Yeah, we had resorted, I think. So, oh, this is before we even sorted the thing. Okay, so now SPSS needs some instruction to let it know what kind of data this is. You'll notice that there's a little ruler next to height and a little set of three different colored balls next to gender. Okay, what it's doing there is it's taking a guess at what variable type this is. So when we gave it just zeros and one, it said to itself, gee, that's probably a categorical variable. That's why it's got those three different colored balls. And on the height, because it was a numbers, it's so many different numbers, it guessed that that was scalar, right? And it guessed correctly in this particular case. But in any case, we need to go to the variable view. Remember, this is the data view. We need to go to the variable view. And the variable view has two rows, each representing a column or a variable on the other side, okay, on the data view. Okay, so let's take a look at this. Height and gender are both in there as numeric variables. In other words, they're numbers. They're entered as numbers. This is the maximum width, the number of decimal places that we expected to have. I guess these were whole numbers. Yeah, they were all whole numbers. Okay, we could have said one decimal place if we wanted to. Well, now the next thing we get here is label. Now, label is there. I can spread this out if I want. Label is there in case you wanted to use something other than the variable name on the tables and charts, right? So instead of height, we might have wanted to have it appear height of students. Students. Okay, under gender, we might want to put sex of subject. Okay, instead of gender. Just, in this case, gender and height are already pretty descriptive. I might not even bother with a label, but in a lot of these things, you'll have a cryptic variable name, and you might want to do that. Okay, so under values, this is our opportunity that if we're coding this information, categorical information, into numbers like we just did for gender, this is our opportunity to tell SPSS what those codes are. Okay, so for height, we're not going to bother with values because the value is just whatever number is typed in. But under gender, when we take a look at gender, we want SPSS to know that if it sees a 0, that represents a male. And click add. If it sees a 1, we want it to give it a label of female. And click add. And then you got to click OK to make sure it records it. So if you ever want to check that, you can just click in here and it'll bring it back up again so you can see how it's coded. Okay, so what do you want to do with missing values? In some cases, we might want to handle missing values because the person refused the information different than missing values because it wasn't appropriate to that subject, or missing values because the researcher forgot to ask or something like that. We might want to code them differently, but in this case, we're not going to bother doing anything with missing values. We're just going to ignore them. Okay, so again, you get columns on the output. How wide are the columns? 11 is more than enough for what we need. What kind of alignment do you want in the columns? Right, left, center. And then under this next column, it says measure. This is important to us because that's where you define what kind of data set it is, what kind of data it is for SPSS. So height is scalar. If I click in here, I can change that to ordinal or nominal. Notice it doesn't bother asking you discrete. It doesn't bother asking you, a million other subcategories that we gave you. Your choices are just scalar, ordinal, and nominal. So in the case of height, it's scalar. Same as that same thing as numerical. In the case of gender, it's nominal. You could say in some cases ordinal instead. For gender, it does the order doesn't make a difference. But if it were, for instance, for grades, like good, fair, poor, or something like that, we might want to define that as ordinal instead of nominal. But for us, nominal is just fine. So now I'm going to go back to the data view. Click here, or you can go up to view and click data. Okay, now notice it's filled in for me all the different values for the zeros and ones automatically. Okay, if I want to see that, if I want to see that, fine. If I don't want to see it, I can go up here to value and go down to here, the value labels. Notice it's checked off. I can tell it to hide those. And it goes back to 0 and 1 in case I wanted to see what they were. If I want to bring it back again, I can go back here and say this again. Okay, so now, okay, so now I am going to go in here and I'm going to say, okay, so let's go ahead and do some analyses with this. Okay, let's start with the nominal data. Okay, so what can I do with nominal data? If I want to analyze nominal data, I'm gonna get descriptive statistics. What kind of information am I really interested with nominal data, males and females? Just that data alone. Don't forget about the heights. What can I do to describe males and females in my subjects here? I can count them, right? That's really not much else I can tell you besides how many males and how many females there are. So we'll go into frequencies. And in frequencies, we can tell it that we want to work with the nominal data, right? The sex of the student, okay? And we want to get various kinds of information. Statistics don't really apply here, right? These numerical statistics don't apply. Let's go into charts. Well, we can ask it to give us a bar chart, right? And in that bar chart, we can either have it display it as the percentages of males and females or the total number of frequencies of males and females. I'm going to leave it as numbers. Okay, I'm going to click OK. And then SPS opens that same output table and drops in the output for this analysis. Okay, so what does it tell us? It tells us that we had 119 males, 262 females in this sample. We had 68%, 69% of the sample was female. And here's a bar chart that shows us the relative frequency of males and females in this sample. Okay, so interesting stuff, right? So now what about my numerical variable, my height? Let's take a look at that. Analyze, descriptive statistics. I'm going to go a little bit further into descriptives here. Okay, and here I have one box over here. I can move height over the students, right? The student height over to the variables. And in the options, I can ask for the median, the standard deviation, the variance, the minimum, maximum, a lot of the stuff we already did in Excel. I'm going to click continue and say OK. And again, it opens the output window and I get my output results. What do they say? They tell me, so I can pull this up a little higher so you can see it. Okay, they tell me that that there are 379 values. The lowest was 56, the highest was 91. Sounds familiar. The mean was 67.09. Sounds familiar. The standard deviation was 4.1. The variance was 16. So it gives me statistics for the center and the spread of the heights in this sample. Okay, so now what did we do next? We broke it up into two groups, males and females, right? Now, if you'll notice that when I went in to analyze descriptive statistics, descriptives, it did give me an opportunity to break it up into two groups, right? So in order to do that, I have to go to the next step. Analyze, Descriptive Statistics, Explore. Okay, and in Explore, I can move the height into my analysis here, which is, it calls it the dependence list, but that's what we're going to find, the average, the standard deviation, so on and so forth. Okay, and then there's another box here where I can move the subjects, the nominal variable, which is the gender or sex of the subjects. What does factor mean? Factor means to break things up, right? So we're going to break up this data into males and females. We're going to break it up into what we put into the factor list. I'm going to click on statistics. Now, statistics, it doesn't give you a lot of choices. It just asks you if you want them or you don't want them, right? So I'm just going to leave it that we want them. In plots, we have a few more choices. Do you want to see a stem and leaf plot? Do you want to see this? Do you want to see a histogram? Let's make it give us a histogram, right? Because we didn't get that before. How about a box plot? You see box plot here anywhere? No, it doesn't look like it, right? However, just dirty little secret, it always, Explore always produces box plots. When you have more than one group, it will produce side-by-side box plots, kind of like Levi was using before. So I'm going to click continue, and I'm going to say okay. Okay, so let's see what comes up in our output box. Now this time we have two groups of statistics here. We have means, standard deviations, minimum, maximums for males. Notice 70, almost 71 inches for males, and the means for females almost about 65 inches, and the standard deviation for each of the two groups, and so on and so forth. Pretty simple, right? SPSS really did all the heavy lifting for us. I can further go down here, and I can see a histogram for gender, for male, right? And notice that we have a very low value here for gender, for height. We have a very high value for height. Looks to me like we might have some outliers when we look at the box plot for males. How about females? Females, oh, look, this, well, now I know it. Now we know there's an error entry because there's presumably a female in here that's 8 feet tall. Right? 8 times 12 is 96, a little less than 7.5 feet tall, 7 foot 6 inches or 7 inches, right? So that's probably a typo or something like that. Maybe it was meant to be 61 or 51 inches or something, right? So that's probably wrong. That's truly an outlier that you might want to take a look at to eliminate. You might have some other outliers too, but maybe they're not really so far out. Okay, so these are stem and leaf plots. Don't worry about them for now. And here's our box plots. And indeed, take a look at the males. Indeed, we do have a number. We have at least one outlier, which is that person that's really short, right? And then for the females, we have a few outliers, including that, look at that really tall person all the way up here. That's truly an outlier. In fact, if I eliminated that one, these other outliers might go away also, might change it a little bit. Okay, so let's take a look at this. Where would we expect, if I look at this box plot, what is this bar on the top? What does this feather, this horizontal line on the top represent? Represent the maximum height for males. What does the box represent? It represents the interquartile range, right? So that means the top of the box is the 75th percentile. 25% of the people are taller than that. 75% of people are shorter than that, whatever that is. Looks like about 74 inches, right? And the bottom line represents the 25th percentile. Hopefully that'll go away. There we go. The bottom part represents, the bottom of that represents 25th percentile. That dark line in the middle is the median, not the mean, the median, right? Okay, and then that feather at the bottom, if there were no outliers, that would represent the minimum value. But there are a couple of outliers, so SPSS just calculates that based on 1.5 times the interquartile range. It just took this, took a 1.5, drew the line there, and anything above that, it stuck out. That's arbitrary. You probably would not eliminate these higher values just on that basis alone. So here's the females. Now, look at the median here. The median is not anywhere in the middle of that box, right? What does that tell you? That tells you that maybe this is a skewed distribution. And here's the female values. And it's skewed because this very extreme value here, the mean is pulled away from the median. Okay, and in fact, you probably see this here for females. The mean is 65, and the median 65.3. Well, it's not that dramatic because it's such a big sample, but the mean is greater than the median because of this extreme value that's out here. Okay, so it's right. This is right skewed. Okay, and it shows up here in the box plot as well. Okay, so that's how we would calculate something like this. So I'm going to ask you. I have another data set here. That other data set is called car weights. Okay, here's car weights. I'm going to ask you to just simply, for now, on your own, calculate the average, the mean, the median, the standard deviation, and the variance for the weights of these cars. Okay? That's your job. You're going to give you about 10 minutes. You could do it in SPSS, or you can do it in Excel. If you're really sharp, you'll do it in both. You'll be able to, in other words, you'll be able to import the file into SPSS and do it in SPSS as well. When I'll give you about 10 minutes to do that, and then we'll do it together, and then we'll move on to using SPSS exclusively to analyze a kind of a semi-real database as well. I'll give you 10 minutes. You guys want the light on or off? On? What? On. Okay. No, I can't get on. It's other schools, yeah, you know, the school, you know what it is, some of the schools, you guys pay like a technology fee, right? Depending on what school it is, they spend it different ways, right? So one of the schools, they have invested in a license for SPS, that's for the students in that school, but that meant we had something else. So, yes, I was hoping I could find a way to cheat, anyway, but. Yes. Okay, so. I do that all, by the way, I do that. We saw me do that. Oh, that's the count, that's the way it's derived. In other words, that's where it comes from. You don't have to do that. You can just have the variance.
It's really Wednesday.
Okay, different one that SPSS calculates.
No, I don't want that if I put the variance off. So like I literally did that. Like,
How did you? Around
it was like by like three points. Like I got 67, and then when I just do the variance function,
Save that file and email it.
Okay.
I'll take a closer look at it.
Okay.
It should come out the same. There are some things, I know you might have heard me mention, that there are certain things like calculating the median. You could calculate the median just by looking at the list of numbers and looking for the middle.
Yeah.
And then if there's two middles, you just average two. Then on the other hand, you could calculate it by looking at that and calculating the mean and the standard deviation. And using that to calculate what the median should be. Or you could do it another way, or another way. So there's some statistical function that, depending on who you use to calculate it, like I think the homework, you might notice that it's different when you do it by Excel.
Oh, really?
When you do it by SPS,
Yeah.
it's just kind of interesting. The variance should come out the same.
Okay, well, yeah, so this is the homework, but I just want to confirm that, so I subtract like each one from
Did you divide by n minus 1?
by n minus 1.
Right. Remember, if you're dealing with the population, you calculate the variance, you divide by n. If you're working with a sample and you calculate the variance, you divide by n minus 1.
Oh,
It's
so
12
the
degrees
count,
of freedom.
the count minus one.
Right, exactly.
Oh.
That's the difference.
Wait,
Yes, sure.
So,
That's why I'm here.
I know. All right, so this is the mode.
Yeah, you want to know something? And you know, values the same.
Oh, they don't do that.
That's what I'm talking about.
Okay.
Yeah, that's what I'm saying. Oh, it's such a goofy thing to try and work with numerical variables, that you're better off just worrying about that when you're using categorical variables.
Average, median,
Standard deviation and variance. Okay, guys, I'm gonna interrupt you guys now because I don't want to spend too much time on this. You can always go back and play with it some more. I'm just gonna actually do this real quick so I can move on to another data set, which will prepare you for doing the homework, the assignment. Okay? So I'm gonna calculate the average equals escape equals, why is it over there? Come on. Skip, click in there. Equals average, parentheses, and the list of weights, which is B2 through B26. And the average weight is 4,037 pounds. And the median weight equals median. Okay, and it's going to be same range, which is B2 through B26, and the median weight is 3,863 pounds. The mean is quite a bit more than the median. What does that suggest to you? Suggests that it's a skewed distribution. Is it skewed positively to the right, or is it skewed negatively to the left? The mean is more than the median. So the mean is being pulled away from the median because there's some cars that weigh, there's a few cars that weigh a really lot, like Hummers or something like that, right? So it's positively skewed or right skewed, okay? Because I can tell that because the mean is bigger than the median is, a lot bigger than the median is. And in fact, if we actually did this distribution here, we'd notice that there it is, there's the Hummer, that's the one that's doing it, right? And there's also, look at this, the Yukon is anybody own one of these beasts here? No? Okay, good.
So if the mean is above the median, it's right skewed, is that?
Right, exactly, because the mean is being pulled away from the median by high value. The mean is dramatic, and we're not talking like a little bit here or there. You know, we're talking about that if the mean is pulled away from the median significantly, it's because there's extremely low values or extremely high values that are kind of outliers that are pulling it away from the median. So it's not quite normally distributed, it's skewed. Again, don't worry about that. We have ways of dealing with not perfectly normal distribution that we're going to learn about later. Okay, so measures of variability. I'm going to use variance. And okay, the variance. And let's see what the variance is. The variance is 96,000, whatever, that's big. Okay, the standard deviation is going to be square root of that. And the standard deviation is really the one that we wind up using. And the standard deviation, whoops, what did I do there? Did I B2 through B26, B2 to B26? Did I left out a V. Okay, there we go, it's 981 pounds is the standard deviation. There is a lot of variability here, right? There's like 2,000-pound cars, there's 6,000-pound cars, 2,460-pound cars, and so on. So there's a lot of variability in these car weights. So that's interesting. I just wanted you guys, before you left here, to at least try this. So now, what I would like to do, though, is I want to say to myself, now, the reason why I'm spending so much time on this, we're going to do a lot of exercises doing this kind of stuff, is because the feedback that I get from other people teaching the courses you're going to be taking next semester, a year from now, and so on and so forth, is that they want you to be practiced and good at using these tools, SPSS, Excel, for analyzing data, producing tables that you can use in reports, producing charts, histograms, box plots, and so on and so forth. All sorts of like ways of displaying and working with data. They want you to be prepared to use that on a practical basis. So it's really nice for us to talk about a lot of theoretical stuff, but they want you to be able to put this into practice. So let's imagine next semester you are taking an epidemiology course and somebody says to you, we want you to investigate whether or not smoking affects the birth weight of infants. Okay, say to yourself, well, gee, where am I going to get data like that? Who might have some data like that? Well, it happens that North Carolina has data that for every individual birth that takes place in that state. We have a subset of that. We have 800, a random sample of 800 of those births as a sample. It's on Blackboard right now. One of the ones I suggested you would download it if you had a chance to do it. It's called NC Birth 800, something like that, mod or something like that. I think I modified it at some point, changed something about it. And you should be able to download that to your desktop. I'm going to open that here. I think I downloaded it to my desktop. I'll find out very quickly. I'm going to go into SPSS. I'm going to say to open data. Since it's an SPSS file already, I don't have to change that file type. And I don't see it there, so I'm going to have to go digging for it a little bit. Let's see, Tony School. Should be in here somewhere. Maybe I should just go back and get it. Maybe it's in here. Nope. Let's try this one. Nope. Maybe it's in there. Nope. Yeah. Okay, I got to go back and get it. Here it is. Here. NC Birth 800 mod SPSS. I'm going to say right click or control click, save link as, drop it on my desktop. Now, if you already have it on your desktop, you could just double click this and it will open SPSS for you. Okay, hopefully that downloaded now. So now when I go into SPSS and go to my desktop, I will see it there. There it is. Okay. I'm going to open this. And I'm going to take a quick look at this file now, just in terms of understanding what it is, what variables are present. Okay, so did it open? That's not it. Where'd it go? Nope, that's the output window. Try this again. Oh, whoops. What's that? Oh my goodness. Yeah, there you go. Say yes to that. I didn't see that down there. Thank you. I appreciate that. Otherwise, I would have been playing with this for an hour probably before I realized that. I noticed that SPSS does sneaky things like that. Sometimes it'll drop an alert behind the window. So you'll be looking at that window. You'll have no idea it's waiting for you to answer that until you finally figure out to move the window so you can see it. Okay, so let's see what we have here. We have a number of variables here. 1, 2, 3. Remember, the columns are the variables. 4, 5, 6, 7, 8. Looks like about 12 variables here. If I go to the variable view, it'll summarize those for me. You can see the variables. These have already been coded for you. At some point, I'm going to ask you to code a variable set on your own. But for right now, I've coded these for you. So for instance, the first variable, plurality. Plurality means the number of children during that birth. In other words, would be 2 for twins, 1 for a single birth. The gender of the child, sex of the child, the age of the mother. Notice how the variable name is mage. That wouldn't mean anything to some third party that would be reading a chart you're going to make. So we give it the label age of mother, in parentheses years. We give it that label so when SPSS produces charts, it doesn't use age, it uses age of mother instead. So it makes more sense. Okay, gender of the child is coded so that 1 is a male child and 2 is a female child. Marital status is coded. 1 is married, 2 is not married. And we were interested in smoking. Okay, did the mother smoke during pregnancy? Mother did not smoke during pregnancy. Mother did smoke during pregnancy is 0 and 1. It's coded so when we work with SPSS, it's going to remember to substitute that for the numbers that the entry that people put in there, which the coders put in there, which was 0 and 1. Okay, so let's take a look at how we might do this. let's see. So T ounces is the weight of the child in ounces. T grams the weight of the child in grams at birth. So these are numerical variables. See, they're scalar. And smoking status is a nominal variable. Mother did smoke or did not smoke, or consumed alcohol, did not consume alcohol. So let's see how we might analyze this data. So I'm going to go back to the data view. Okay, and I'm going to say analyze. So descriptive statistics. So what do you guys think? What do you think I might do at this stage in order to analyze whether or not mothers who smoked had the same birth weight, average birth weight baby as mothers who did not smoke? Okay, so am I going to use frequencies, descriptives, or explore? Any guesses there? What's that? Yeah, the only problem with descriptives, remember when we did descriptives? It only did it for the whole group. There was only one box there. I couldn't factor it into male and female, right? So maybe I should go a little further and use explore. Let's go down to explore. Okay, and if you went into the wrong one, you'd figure it out pretty quickly because you wouldn't get what you were after. I'm going to go into explore. Okay, so now under the dependence list, I'm going to put the variable that I want to find the average of, the numerical variable. So what would that be? That would be the weight of the child. What do you guys think, ounces or grams? What are you guys more comfortable with? What do you think, grams? I guess more nowadays hospitals work in grams, right? My wife is binge watching ER, and there was this thing about this premature infant and whether they should try and save it or not. And the guidelines in the hospital, it was over 500 grams. They would make an effort to save it, right? So it was 506 grams. I don't know what I didn't watch the next episodes. I have no idea what happened. Okay, so at any rate, all I know is that Kovac got injured they had to go rescue Kovac from the whatever, and then the helicopter fell on that other guy. What was his name? Anybody watch that series? You guys, come on, you're nutrition, you're health students. You must have watched. Oh, you're too young though, right? Oh yeah, you're too young. You're too young for ER. ER was like in the late 90s, right? Early 90s or something. I'm sorry. At any rate, the weight of the child, I'm going to put the weight of the child into the dependence list, right? So now I'm going to break that up. I don't just want the weight of the child, all of the children. I want to see the average weight of the child for mothers who smoked versus mothers who did not smoke, right? So what am I going to put into the factors list? I'm going to put the categorical variable, which represents mother's smoking status, right? Which is going to be, let's see, mother weight gained, mother smoked during pregnancy, that variable, smoke. I'm going to move that into the factor list. Under statistics, what's that? You could put, yes, it'll do two separate analyses. I think you can put two in the factor list. Okay, I'm not going to muddy the waters for this right now. You can do them separately too, right? So I'm gonna leave smoke during. So you could maybe you wanted to check both smoking and alcohol use or something like that. So I would probably do them separately anyway, just keep it a little cleaner, keep the tables a little cleaner or something. But at any rate, say smoke during pregnancy. In statistics, it's just a matter of it's going to do it or it's not going to do it. 95% confidence interval, you'll figure out that stuff later on, not a worry. Okay, so for plots, maybe I'm interested in histogram, see how normally distributed. These are not going to be normally distributed. Why? Because you know that, you have certain normal birth weights, right? And then like a really heavy baby would be a little bit heavier, but you got premature babies that are much lighter than normal birth weight babies. So it's going to be skewed to the left. We can almost visualize that, right? So I'll put in histograms if for no other reason, it might be interesting. So I'll click continue and I'm going to click OK. So we expect an output table to come up. And sure enough, in this output table, it tells us that among mothers who did not smoke during pregnancy, the average birth weight was 3,300 grams, 3,330 grams. And the average birth weight for mothers who did not smoke during pregnancy was 3,100 grams. So they're quite a bit lighter than the average birth weights of mothers who did not smoke. Could be a lot of reasons for that, right? May not be smoking. Could be that mothers who smoke don't visit the pediatrician, the obstetrician as often. They don't take care of the health. They have other bad habits. Their nutrition is bad. Could be a million other reasons by smoking, because we'd have to worry about all those various other factors. But right off the bat, we can compare these two based on the average. We could look at what the range is. We can look at what the variability is. Look at the standard deviation, 570 for mothers who did not smoke, and 640 for mothers who didn't smoke, rather, and 540 for mothers who 570 for mothers who didn't smoke. So there's much less variability. There's less variability, but a lower average for mothers who did smoke, whatever that might mean. Okay, and then we have our histogram, and you can see here's the histograms for mothers who smoked during did not smoke during pregnancy. These are premature births, so these are low birth weight babies, and notice how it's skewed to the left. So when we look at the box plot, we would expect to see that median pulled to the pulled down, to a lower weight, right? And here it is for the other group. Oh, and this one there was only one. This is the reason why this is kind of freaky is because there aren't that many women in the smoking category. I think in the alcohol one, I don't think you can really do much analysis because I think the sample size is so small. Okay, so let's take a look at what it looks like in the box plot. Look at these outliers. Look how many outliers that there are here because of all these low birth weight babies. If these had been included, then that bar here would have been pulled all the way down here. SPSS excluded so many of these values that you don't see the skew here, right? It just dumped all those values. Now, can you justify dumping those values? Not really. You'd have to make a better judgment about what reason you would use to dump those values in this particular study that you're doing. So now, what would you do with this now that you have it? Well, you might want to communicate this information. You want to take this table and put it into a document that you're preparing as part of a report, a paper, a capstone. You guys are doing capstones now, right? You guys do capstones, yeah. Right, so that's a project. Capstone is basically a thesis, kind of. You have to do data collection, you have to put together a report. You might even have to do it verbally, right? You have to defend it verbally and stuff, right, in addition to a report. So you guys have to be prepared for this kind of stuff. And we're going to get you prepared. Okay, so let's say you want to put this into another document. So I'm going to open up a Word document in the last 3 minutes we have. Again, I don't want to go long today. I kept you guys late last time. And my version of Word is funky. I had at least one or two people that also told me about this. They had the same problem. I have an old version of Word. So if I go in here, I can click on this table. Notice now it's surrounded by a box after I clicked into it. Now it's clicked on. I can say copy. I can right click and say copy. Then I can go into this Word document and I can say paste. Edit. Up, I don't see it there. Come on. Control C, Control V. It's not working for me. Yeah. Like I said, I have a little bit of an issue with Word. I have another program here. Let's see. I didn't pass around in attendance. I should though, right? Shouldn't I? Let me send something around real quick. On your way out, you can sign it. Geek. Big up piece of paper. Why don't you just write your name on it, and sign it, and send it around. Okay, sign that for me. I need that because the register is going to ask me within a week or so. It's going to ask me to confirm who's attending the class, who's not attending the class. In the future, I might take attendance. I might skip a week or something like that. The nutrition students know they have to come in, and that's part of their participation. The non-nutrition students have a choice. They got to come in for exams, but not necessarily for the individual classes. They can do that online. I'm using a program called Openoffice, which is kind of like a free version of Word, because I think this one will actually let me paste it in. See if that's true. Well, the long and short of this is, let me copy this one. Control C, Control V. There you go. Okay. It did a little bit funky, but if you see that it doesn't line up very well, you can always highlight it and change the font size so that it lines up a little bit better, like that. Okay, so I can copy and paste in these charts and tables.